The robot revolution has grown exponentially in the last couple of decades and is showing no signs of slowing down. Nowadays, most of the cars on the road were manufactured using robots. There are robots helping spacecraft dock at the International Space Station, and modern families may even have one faithfully vacuuming their lounge room floor. These technological advances have been accredited to autonomous motion. An autonomous robot is a robot that can perform behaviors or tasks with little or no human interaction or interface. A fully autonomous design can gain information about an environment, work for an extended period of time without any human intervention, move either all or part of itself through its operating environment without human assistance, and avoid situations that are harmful to people, property, or itself unless those are a part of the design specifications. Autonomous design dates back to the 15th century, where Da Vinci's self-propelled cart was the first of its kind in human history, as well as the first ever programmable machine. Other key moments throughout history was the invention of the Whitehead torpedo in 1866, the Unimate manufacturing arm in 1961, and what we are seeing nowadays with Tesla's autopilot range in their vehicles. Autonomous designs have three main components. Firstly, sensors must be able to detect things such as images or sound accurately. Then the effectors have to be flexible and move fast enough to complete the task, while the control system must make all the decisions necessary to get the sensors and effectors to work together without causing any problems. The three levels of autonomy that will be discussed in this video are reliant, assisted, and executive.
In terms of automated movement, reliant autonomy refers to the pre-programmed functions performed by robots to accomplish a very specific task within known parameters. While reliant autonomy has its roots in the Industrial Revolution, reliant autonomy as we know it came to fruition in the 1970s with advances in computing. Reliant autonomy is predominantly used in the manufacturing and industrial sectors, where automated robots are used to handle materials, weld parts, and assemble products, among other functions. Three separate forms of technology are needed for reliant autonomy: feedback systems to sense the environment they are in, computer systems to interpret these sensors, and lastly, physical agents to enact what the computer system interprets. Advantages to reliant autonomy in manufacturing include increased productivity and higher output rates, along with higher quality control and improved safety. However, some drawbacks of reliant autonomy are higher initial expenditure, less flexibility, and the ethical concerns around workers' job loss. Looking to the future, lights out manufacturing, meaning 100% automation with no human workers, is expected to become fully realized as part of Industry 4.0.
Assisted autonomy is the combination of both technology and artificial intelligence to provide a product that is capable of thinking for itself and completing set tasks when given by the user. Assisted autonomy was first conceptualized through Greek mythology with the idea of metal robotic slaves. However, the first assisted autonomous robot, Shaky, was only created in 1966. The first household autonomous product, the Roomba, was released in 2002 as a robotic vacuum cleaner. Some current applications of assisted autonomy in the consumer market are robotic vacuums, mops, cars, and even drones. On the industrial side of things, assisted autonomy is mostly used in freight and production lines, and also manufacturing. Assisted autonomy uses four different sections of components. It uses feedback systems, such as sensors and cameras, computer systems such as PCB and operating system. It also uses physical components, such as motors, actuators, and pumps. Human interfaces are also used, such as buttons and screens. Some advantages of assisted autonomy is the increased efficiency for both consumer and industry, the lowered usage of energy and materials, and also the overall improved safety. Some of the disadvantages, however, is that autonomy is expensive, and it can also have possible errors in its working system.
Executive autonomous motion defines an object or system that can operate, make decisions, and adapt to its surroundings without any further human input. Although the concept originated in the 1940s, executive autonomous motion has only become available in the past 2 decades. 2007 saw the first trip completed by a fully autonomous vehicle. Although vehicles are the priority focus for the consumer market, executive autonomy is also applied in the fields of robotics, trains, micro-aerial vehicles, and health. Google's autonomous project vehicle known as Waymo combines multiple input systems. Boston Dynamics are developing humanoid robots, such as Atlas in partnership with the Defense Forces. Various technologies are combined to achieve executive autonomy, the two focal technologies being LiDAR and stereosonic vision. LiDAR uses numerous lasers that move on a 360-degree axis. The light beams are projected back off the surrounding environment and a 3D map is then formed. Stereosonic vision uses various cameras which combine images to provide a similar mapping. All information is processed through a computational membrane. Advantages of executive autonomy includes improved safety, flow rate, and reduced deaths on the road, increased sustainability due to zero vehicle emissions, and reduced strain on soldiers. The downfalls of this autonomy includes the exorbitant costs and the disposal of non-autonomous vehicles.
Some ethical dilemmas to think about is that there is possible job loss, a robotic apocalypse, and that not all consumers like robots. In summary, automation is the combination of technology and AI to provide an easier everyday life for both consumers and industry.